2024 A-Level Combined Mathematics Paper 1 Part A question number 9. This is the circle question. The question says, let A be given by the point -1, 1 and B be given by the point 3, 3. Given this, we are asked to first write down the equation of the circle S with AB as a diameter. After this, we are asked to show that the circle x squared plus y squared minus 4x minus 5y plus 9 is equal to 0 touches the circle S internally at the point B. So there are two circles, one is S and there's this other circle here which in our question when writing the answer we'll call this S dash, and we have to show that these two circles touch internally and they touch internally at the point B. Now to start off this question, the first thing we need to do is to write down the equation of the circle S with AB as a diameter. Now from theory, as we discussed, we know that if you have 2 points, say x1, y1 and x2, y2, and you have a circle that has these 2 points as the endpoints of a diameter like this. If we have this where these 2 points here are x1, y1 and x2, y2, then the circle here is given by x minus x1 times x minus x2 plus y minus y1 times y minus y2 equals 0. This is the equation of a circle with x1, y1 and x2, y2 as the ends of its diameter. Now in this particular case, we can see since AB is a diameter of the circle S, the points A and B are the endpoints of the diameter of the circle S. Therefore, we can say if we substitute in these 2 points in those formulas, we are going to get the equation of the circle S. So we could say something like from theory, and then we can write that the circle S is given by the equation x minus x1, which in this case x1 is -1, so we have x minus -1, which is going to be x plus +1 times x minus x2, which in this case x2 is 3, so therefore we have x minus 3 plus y minus y1, which is 1 here, so y minus 1 times y minus y2, which is this thing here, 3, so we have y minus 3 is equal to 0, and therefore the circle S is given by this circle here. Now if we simplify this down, we can see we're going to get x squared and then minus 3x plus x and then 1 times 3, -3 here, and then here we're going to get y squared, y times -3, -3y, -1 times y, which is going to be -y, and -1 times -3, which is going to be +3. So we're going to have +3 here, -3 here, cancelling out to give the constant term of 0. Now in this case, we know that if you have such a circle, then if we simplify this down into x squared plus y squared plus 2fx plus 2gy plus c equals 0 format, then f and g are going to be the negative x and y coordinates respectively of the center point of our circle. So basically our circle is going to be of the form -f, -g as its center, and we also know that we can find the radius squared in terms of c, f and g. So we know, given this kind of structure, c is going to be equal to f squared plus g squared minus r, and therefore if c is equal to this, then r is going, or rather r squared, and therefore r is going to be equal to the square root of everything else, which is going to be f squared plus g squared minus c. Now we can use these two formulae in order to find the radius and center point of circle S, and that's going to be important later when we consider the internal touching of S with the other circle. So if we write down S in terms of this format, we can see we are going to get a coefficient of x of 1 times x and -3 times x, which is going to be -3 plus 1 or -2 times x, and therefore we can write this as -2 times 1, or we could write as plus 2 times -1 times x and then plus 2gy. Similarly, we can see we're going to get -3 and -1, which is going to be -4, and we can write that as plus 2 times -2 times y, and then as for the constant term, we're going to get 1 minus 3, which is going to be -3, and -1 times -3, which is going to be +3, added together is going to be 0. So plus 0, which I can just ignore, equals 0. Now according to this, we can say the center, let's say C1 of S is given by, and we can see we have -1 here and -2 here. So in that format, F is -1 and G is -2, and therefore the center is going to be -F comma -G, which is going to be 1 comma 2. Now there is actually a different way that we could find this exact same center. We can say, since A and B are the endpoints of our diameter, the midpoint of AB must be the center point of the circle. Since if you have any circle, half of the diameter is the radius, and therefore if this is a straight line in between A and B, then this is going to be equal to this length, and therefore the midpoint of the two is going to be the center point of our circle. So we could do that, and we could average these 2 points, and we can say -1 plus 3 is going to be equal to 2. 2 divided by 2 is 1, and similarly 1 plus 3 is 4, divided by 2 is 2. So anyway, we have found the center C1 of the circle S. Now similarly, we also want to find the radius, let's say R1 of the circle S. So we can say radius R1 of circle S, or we'll write it in simple R. Simple R1 of S is equal to, and we can again find this in 2 ways. We can either find it using the formula that we wrote, or we could find it by using AB length and say that the radius is equal to AB length divided by 2, which is equal to 1/2 of, and considering the distance between A and B, we can see the y distance is 3 minus 1, which is 2, and the x distance is 3 minus 1, which is 4. So minus 1, which is 4, and therefore we're going to have 2 squared plus 4 squared, which is going to be equal to 20. We have 4 plus 16, which is 20. So the square root of 20 times a half, which we can see is going to be √2 times √5. Rather, I should apologize. √4 times √5. √4 times √5 divided by 2. √4 is equal to 2, and therefore we can cancel these two, leaving us with √5. And therefore the radius of our circle is √5. Now similarly, we also need to consider the other circle, which is this circle right here, which I'm going to call S dash. So I'm going to say, let S dash be given by the equation x squared plus y squared minus 4x minus 5y plus 9 equals 0. Now according to this, we can see minus 4 is of the form plus 2 times minus 2, and similarly minus 5 is of the form plus 2 times minus 5 over 2, and therefore in this circle, if we write it in the form x squared plus y squared plus 2fx plus 2gy plus c, we can see our f is going to be equal to minus 2, and our g is going to be equal to minus 5 over 2. And therefore, if we use these two, we can see that the center point, we can say center, we could say therefore, center, let's say C2 of S dash is given by that number negative divided by 2, which is going to be negative 2 over 2, sorry, negative 2, which is going to be equal to positive 2, comma, and then the other coordinate is going to be equal to negative 5 over 2, which is going to be equal to 5 over 2. And therefore the center point here is 2, 5 over 2. Now considering that, if we then take a look at the radius, we can see the radius R2 of S dash is equal to, and for this one, we will use the formula of the square root of f squared plus g squared minus c. So in this case, we can see f squared is going to be equal to negative 2 squared, which is actually going to also be equal to 2 squared. So we can, we could use that as well, but we'll do it properly and substitute f squared as being equal to negative 2 squared plus g squared, which is negative 5 over 2 squared, minus c, which is 9, so minus 9. Now if we simplify this, we can see we're going to get the square root of negative 2 squared, which is going to be 4, and then minus 5 over 2 is minus 2.5 squared, which is 2.5 squared, or 25 over 4, so we can write plus 25 over 4 minus 9. And we can see if we take this all under common denominator of 4, we're going to get 16 plus 25 minus 9 times 4, which is 36. So 16 plus 25 minus 36. And we can see if we subtract these two, 36 can cancel for 16, leaving us with minus 20. 25 minus 20 is going to be equal to just 5. So therefore on the inside we have 5 divided by 4. Now from this we can see that when you take the square root, our value is going to be equal to root 5 over 2. So therefore the radius R2 of S dash is equal to root 5 over 2. Now considering these two circles, we can see if we consider the distance between C1 and C2, if we consider C1, C2 distance, the distance from C1 to C2, where C1 is 1, 2 and C2 is 2, 5 is equal to the square root of the x distance, which is 2 minus 1, which is 1. So 1 squared, which is 1, plus 2 minus 5 over 2, which is 2.5 minus 2, which is 0.5. So 5 squared, which is 1 over 2 squared, which is going to be equal to, it's going to be equal to 1 over 4 plus 4 over 4, which is 5 over 4. And the square root of 5 over 4 is root 5 over 2. Now we can also see, if you consider the value root 5 over 2, root 5 over 2 is also equal to R1 minus R2. Since we can see here, R1 is equal to root 5 and R2 is equal to root 5 over 2. Now, from theory we know that if ever the distance between the two centers of two circles is equal to the absolute difference of their two radii, then the two circles intersect internally. Now here we can see, since R1 is bigger than R2, it means that the circle S is bigger than S dash. And therefore, if we draw the two circles, we're going to have set up like this. Where we have S dash on the outside, this is S on the outside, and S dash on the inside like this, where S dash is touching S internally at some point. So with this, we now know that S and S dash touch internally. So we can see here, if we write, we can say therefore S comma S dash touch internally. Now I'm going to call this fact number A. Now we were not asked to just show that these two touch internally. We were asked to show that they touch internally at the point B. Now since we already know that they touch internally, and since they don't have the same radius, they must touch internally at a single point. If we want to show that they touch internally at the point B, which is given by 3, 3, all we need to do is to show that B is on both circles with center C1 and center C2. We need to show that B is on both circles S and S dash. Now, considering the definition of S, since S was defined as the circle with AB as a diameter, we know that B is already on S. So therefore, for that reason, we don't need to prove that B, the point 3, 3, is already on S, since it is already by definition on S. What we do need to prove, however, is that the point 3, 3, which is B, is on the circle S dash. We need to show that it's on this circle. If we can do that, then we can say, since B is common to both circles S and S dash, and both of them touch internally at a single point, that single point must be the point B, and therefore both circles touch internally at the point B. So going down, all we need to do is to substitute the coordinates 3, 3 into this circle and see if it's equal to 0. If it's equal to 0, then we can say that B is on the circle S dash. So if we say substituting B into S dash, what we're going to get is x squared plus y squared minus 4x minus 5y plus 9. And if we substitute that in, we're going to get x squared, which is 3 squared, plus y squared, which is 3 squared, minus 4x, which is minus 4 times 3, minus 5y, which is again minus 5 times 3, plus 9. And we can see here, we're going to get 9, 9, and 9, and minus 12 and minus 15. Now adding the 3 9s together, we can see we're going to get 27, and these two are going to be minus 12, and minus 15. And we can see 12 plus 15 is equal to 27, and therefore we have 27 minus 27, which is in fact equal to 0. So we can say here, this is in fact equal to 0. And therefore, B is on S dash. We're going to call this fact B. Now, we can say, since B is on S. From A and B, we can combine these two facts, the fact that S and S dash touch internally at a single point and the fact that B is on S dash, to say that S and S dash intersect internally at the point B. And with that, we have completed this question. Now finally, let's discuss the marks awarded for this question. So for this question, when you write from theory that the circle with AB as a radius must be given by x minus x1 times x minus x2 plus y minus y1 times y minus y2, and you write down this equation right here for the circle S, you get 5 marks for that. Now after this, when you find the center C1 of S by either finding the average point or some other method, and you find it as 1, 2, and you also find the radius R1 of S as being equal to AB length divided by 2, which is then going to be equal to root 5. For finding these two bits of data, you get 5 marks. Now similarly, when you do for S dash and you find the center, which is 2, 5 over 2, and you find the radius, which is root 5 over 2, for finding these two, you get another 5 marks. Now after this, when you find the distance between the two circles C1, C2, find that it's equal to root 5 over 2, and then show that that's also equal to this value minus this value, or rather root 5 minus root 5 over 2, or R1 minus R2. And then using this fact, when you say that therefore S and S dash must touch internally and write down the fact A, for this bit you get 5 marks. After that, when you then say that B is going to be a point on the circle S dash, due to the fact that when you substitute it in and simplify, you get equals 0, and you say that B is on S dash, this gets you another 5 marks. Now they have actually not given a final mark for you writing the final statement saying that B is on S, and therefore from A and B we can say S and S dash intersect internally at B. They haven't actually given you a separate mark for this. However, writing this statement is still important as it is the conclusion of all of your work. So therefore, that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in comments down below. Thank you for watching and goodbye.